Hello, today we will be going through the Unit 12 review. It's mainly area. Number 1, find the area. This is a triangle, and the formula for the area of a triangle is 1/2 base times height. 1/2 times 12 times 4, which equals 24 units squared. Number 2, again, this is triangle. 1/2 the base times height. And if you multiply that out, you get 15 units squared. Third time, again, 1/2 base times height. Get 6 centimeters squared. Number 4, this is a trapezoid. The formula for a trapezoid is 1/2 parentheses base 1, 1/2 parentheses base 1 plus base 2 times the height. Multiply that out, you get 30 meters squared. Number 5, now we're doing composite shapes. Up here we've got a triangle, which is 1/2 the triangle 1/2 base, which is 8 millimeters, times height, which is 2, plus the rectangle, which is base 8 times height. Multiply, add, and you get 72 millimeters squared. Number 6. Again, this is composite. I'm going to split my shapes up right here, and I've got 2 rectangles. Rectangle plus another rectangle. So I've got 4 times 7 plus, let's see, 4 is right here and 2 is right here. So 4 times 2, which equals 36 centimeters squared. Number 7, find the area. This is a rectangle, so it's 1/2 base times height. It's just base times height. Rectangle is base 1/2 times height, just 2/3. Multiply that out and you get 1/3 inches squared. Number 8, again, this is another composite shape. I'm going to split this up into a rectangle. So this will be 6 times 18. And then a triangle, which is 1/2 the base from here to here. Since this is 6 and this is 3, the whole thing is 18. 18 minus 6 minus 3 is 9. The base is 9 times the height, which is shown right here. If you multiply and then add those together, you get 148.5 centimeters squared. Number 9, find the area of the regular polygon. Regular polygon is 1/2 apothem times perimeter, so it's 1/2 times the apothem, 14.49, times the perimeter, which is 12 times 1, 2, 3, 4, 5, 6, 8, because it's an octagon, which is 96. So your answer becomes 695.52 units squared. Number 10, find the area. This is a trapezoid, so I'm going to do 1/2 parentheses base 1 plus base 2 times the height, which is 4. And you get 18 feet squared. Find the area of the regular polygon. 1/2 times the apothem, 5.5, times the perimeter, which is 8 times 5, or 40. Multiply that out. You get 110 inches squared. Number 12, composite shapes. We've got a square, which is base times height. plus a rectangle, again base times height. Add or multiply and add, and you get 27 inches squared. Number 13, find the area of the regular polygon. 1/2 times the apothem, which is 7, times the perimeter, which is 48. Multiply it out, 168 inches squared. Number 14, find the area of the regular polygon. 1/2 times the apothem, 12.3, times the perimeter, which is 80. And you get 492 inches squared. Number 15, it's already split it up into shapes where you've got a square, 6 times 6, plus a rectangle, which is 26 times 8. Multiply and add, 244 units squared. Cooking with gas. Number 16, find the area of the shaded region of the regular polygon. So first we're going to need to find the area of the regular polygon, which is 1/2 times the apothem, 5.5, times the perimeter, which is 40. You end up getting 110. And then we need to subtract away this triangle right here, which is 1/2 the base, which is 8, times the height, which is 5.5. And you get 22, so it's 110 minus 22, which is 88 feet squared. Find the area of the regular polygon. Well, first, we already have the apothem, so it's going to be 1/2 times 10 square root 3, but we need to know the perimeter. Well, seeing the square root 3, I am going to recall that the 30, 60, 90 formula has that in it. I know that this is a hexagon, so each of these are 60 degrees. I've split this in half, which makes this 30 degrees, 60 degrees. I have a right triangle, 30, 60, 90. This is 10 square root 3, which makes this 10, which means this side is also 10. So each of these sides is 20. So the perimeter is going to be 120. So 1/2 times 10 square root 3 times 120 is 1,039.23 units squared. Unit squared. Find the area. We've got another composite shape. I've got one triangle up here, 1/2 base times height, plus another triangle down there on the bottom. It's the same triangle, 1/2 base times height, plus this rectangle in the middle, which is 5 times 2, base of 5 times height of 2. And multiply and add, and you get 12 centimeters squared. Number 19, find the arc length shown. So we're looking for this arc length right here. The formula is x degrees, 45, divided by 360, times the circumference of the circle, 2 pi r, which is 12. Multiply that out, and you get approximately 9.42. In terms of pi, it's 3 pi, because you just do all of these values first and leave pi to last. Number 20, find the area. So instead of using circumference, we're going to use area of a circle. It's x degrees, 100, divided by 360 times the area of the circle, pi radius squared. If you're leaving it in terms of pi, it's 2.5 pi, which is approximately 7.85 units squared. Number 21, find the arc length shown. Arc length is again x degrees, or 90 degrees, over 360 times the circumference, 2 pi r, the radius is 3. In terms of pi, we get 1.5 pi, which is approximately 4.71. Number 22, given the sector area equals 3.93, what is the radius of the circle? The missing piece on this number was that this is 225 degrees. Your teacher should have told you that. With this piece of information, we can fill in our equation, and we get the sector area, 3.93, is equal to the degrees, x degrees divided by 360, times the area, pi r squared. Now we just need to solve for r. If you multiply these out and then divide it over there, you get 2, approximately 2 is equal to r squared. And then you need to square root, and the answer is approximately 1.41. Find the minor arc of CD, so that's this baby arc right here. And the formula is x degrees, 45 degrees divided by 360, times 2 pi r, and r is 15. Multiply it out, and you get approximately 11. Oh, in terms of pi, you get 3.75 pi, which is approximately 11.78. Number 24, find the arc length of CBA. CBA is over here. If this is 120, that makes this 240 degrees. We can use that in our equation. So 240 divided by 360 times 2 pi r. R is 12.2. In terms of pi, we get 16.27 pi, which is approximately 51.10. Number 25, given the sector area equals 1.22, how many degrees is the shaded region? So we know sector area, 1.22, is equal to x degrees over 360 times pi r squared, which is 9 squared. So first I divided by pi times 9 squared. Divide both sides by pi 9 squared. And I was left with 0.0047 equals x divided by 360. And then I multiply both sides by 360. And x is approximately 1.73 degrees. Find the area of the shaded region. So this is a couple steps. First, we need to find the entire area. We've got a composite figure. So I've got a rectangle, which is 6 times 6 plus a triangle, which is 1/2 base, 5, times height, which is 6. And then after we find that, we're going to subtract the circle out of it because this is not shaded. So we're going to subtract pi r squared, pi 2 squared. Multiply that out, and you get 38.43 inches squared. 27, find the area of the shaded region. It's pretty much the same thing, in fact a little bit simpler because it's just the rectangle minus the smaller rectangle. So it's 10 times 12 minus 7 times 2. And you get 106 meters squared. I'm going to pause it right there, and we will continue in the next video, Unit 12 Review Part 2.